Hey guys, RLA Jack here with a quick MATLAB video on interruptions to loops. So there are two main types of interruptions to loops, called a break and a return. And both of them are essentially going to stop a loop in its path, but the break allows the loop to continue to code further down in the function. The return just returns the variables expected by whatever function called the function. So I'm going to write a function, and this function is going to essentially be a random number generator that is going to sample a whole lot of numbers. If a number is less than 0.01, it will just return that number, or the first one of those it sees. Otherwise, it'll return the smallest number. And the way I'm going to do this is I'm going to iterate through a bunch of random numbers, and I'm going to get one of these. So let's get started. So function myRands of, let's say we want to generate n random numbers, and we have a threshold t for how small we need our random number to be, and then that should be it, or how small we want it to be. Otherwise, we're going to get the smallest. I'm just going to do a random number generation, so I can do my random, or my rnums is equal to rand of, and of course it has to be a row vector of 1 by n. And then I will do if, then I'll do a for loop for rnum in the vector rnums. I'm going to run each round of code. First off, and this is where I'm going to do the minimum thing. It will be if, oh yeah, also rmin I'm just going to set to infinity, which is inf, if you didn't know. Also, why is just unused? Okay, cool. So that's not a function name. So if rnum is less than rmin, then we need to set rmin to be equal to rnum, and then also if we get a number that is less than our threshold t, rnum less than t, then we will break the for loop, and this will break out of this for loop, and it will just finish by setting well, it already would be set for rmin would be rnum, so it would just be our result. Okay, so saving that, let's have it generate at 0.01 for 100. And it doesn't return, because of course it doesn't. So the return value is rmin, which is our minimum or minimal number. So that one still, that one dipped below, that one dipped below. Some of them dip below 0.01, others don't. And I'm sure that this would give you a somewhat interesting distribution. Not quite sure what it would look like though. But now we are essentially going to analyze what happened here. So we have our vector of random numbers, rnums. If rnum is less than rmin, then rmin is set to be the value of rnum. So this just changes the minimum value that we're going to give at the end. And then if rnum is less than our threshold value t, then we break out of the for loop. And what that means is we're going to stop looking at other numbers. This is going to be the last time through the for loop, and it's just going to get out here. So that's how we would use break in this case. And since our min is already set to rnum, it'll just have that number in its memory as rmin. Because if this rnum is less than t and it's the first one less than t, then by definition it's the smallest number we've seen. Okay, so the next sort of step is what if we didn't break out of the for loop? And what if we instead just said, okay, return rmin right then and there? It turns out that it will give us the exact same output if we try a bunch of times. So what this return does is it says stop all the code that you're doing, and it is going to essentially it'll stop everything you're doing, and it will act as if it reached the final end in the function right then and there, and it will see what rmin is right then and there, and it'll return what rmin is. So this is a way you can return. In this case, return and break could work sort of interchangeably, but you might, if you have some like further processing to do down here, like rmin is equal to rmin squared or something like that, then break is needed. Otherwise, you can use either break or return. So one last thing. So consider that this rnum is less than t is not this simple, and it's actually a hard calculation to do, and you'd rather not do it if you don't have to. So rnum's definitely not going to be less than t if rnum is not less than rmin. Because if rmin is less than t, then that's a contradiction, and we've already found something less than t before, and we would have already stopped the code. So if rnum is not less than rmin, we could add an else to this, and this else would just have something saying continue. I can't spell continue, but what this does is it says don't do anything else in this for loop. Just go to the next number in the for loop and keep on going. And it turns out that this, if we were doing something computationally intensive for what we're doing down at the bottom, would make this function a nice bit faster. So yeah, consider continue. But continue, return, and break, all of them are useful for doing, for interrupting program flow, particularly in for and while loops. In this case, a for loop, but you can also break in a while loop when certain conditions are met. Okay guys, so that's it for this video and for this section on program flow, and I'll see you in the next section, which will be plotting. Okay.